The purpose of this lab was to analyze a video of an object at constant velocity using Newton's second law. Using the tracker software, I analyzed the video, setting motion points manually with the center of the ball being the center of the point of mass. The system here is the ball, with the origin being the beginning of the clip, which I trimmed to make sure the ball was already at a constant velocity. The origin would also signal where the changes in position would begin to be measured. I then calibrated the video, measuring 1 meter on the table and setting it equal to 1 meter in the video, shown as the blue arrow against the purple x-axis. The positive x coordinates that are measured also indicate the movement of the ball to the right. Here I put a white background to easily show the blue arrow and some of the changes in position of the ball. Here, a scatter plot of the data collected is shown, and the model, which is shown by the thin blue line running through all the data points, was made using two data points that best fit the general trend. The model here shows that the velocity of the ball was approximately 0.817 meters per second. Newton's second law says that the net force exerted on an object is equal to the mass of an object times its acceleration. The acceleration is the change in velocity divided by the change in time. In other words, Newton's second law says that the change in velocity divided by the change in time is equal to the net force divided by the mass. Since there was no change in velocity, according to the model, the net force must also be zero. Since there was no change in velocity, this model and lab shows Newton's first law, which states that an object in motion stays in motion unless acted upon by an unbalanced force. And since the net force is zero, the model accurately shows Newton's first law. There are a few discrepancies between the model and the real data points, but that is due to errors in manually tracking the ball, which led to some of the data points not lying exactly on the model. And since the model is linear, both its second derivative and acceleration would be zero, which would further indicate that the model does agree with Newton's first and second laws.